So we've got our first super ellipse there. So this super ellipse corresponds to the footprint of the building, and what we're going to do is let's just leave that at 100 and let's make a copy of that. So this is the footprint, and this one's going to become the inner drip line. And so for the parameters for that, let's just we need to reset these. So we've actually now got two super ellipses. So I think we can get slightly better match with about, this should be about 0.6. This should be about 0.8. And I'm not really that worried, but I just know that these values give us slightly better matches. Let's just keep that. It should be 0.6, right? And then this should be around 57, and this should be, and this one here is about minus 13,000. So that looks kind of good. So we've got our inner and outer curves there. So now what we want to think about is how do we actually begin using them. The first thing we want to do is set up a structural grid. So let's make a new parameter here, which is going to be a slider, and I'm just going to define it as 100. I'm going to give it the name number of bays, number of structural bays. And so really now this is the scripting part is done. We're going to adapt this slightly to do the section, but really now we're back to standard modeling with Grasshopper. So we can take the results of our script now and just work with it like it were any other curve type. So in here we can do, we want to do a curve division. And obviously I've connected the number of bays to what should be the curve. So let's just fix that. So now we get our evenly spaced points through there. So we're trying to set up structural bays between the inner and outer curve. We want a point that just represents the center of the model. So we do construct point, and then we take a line from there to there. And what we're interested in now is finding the intersection point of the inner super ellipse and these lines. Let's just reduce that down just for now, because we don't really need that many. We probably need 30. Will be fine while we're working on it, and we can adjust it later. So we want to do an intersection. So from the intersection menu, it's physical, it's curve, and I think the way we have to work this is that the ellipse goes into the A curve and the lines go into the B curve, and then we get our intersection points. Now what we've got to be a little bit careful of is that we have this duplication, because our super ellipse, if you remember when we defined it, I said that it's not periodic because the start and end points coincide. So we have to do a little bit of cleaning here, which means that we can use something called curl duplicates. So we want to curl the duplicates from there, and we also want to curl the duplicates from these intersections. These points should be flattened. So we've got two sets of 31 points. We should hide the lines there and then make a new line, which is the so that's our structural base. So let's save this, let's save as, and now I'm going to call this one, so I'll keep the super ellipse separate, Aviva number 1. So what we need for each one of these lines, let's just go into 3D, we need a plane that corresponds with the line and is vertical. So the way that we can do that is we're going to use from the vector menu, a plane which is by 2 axes. These points here, this is going to be the origin, and this line is the x-axis, so that's the x-axis, and then we can use a z vector for the y-axis. And I think if I go into display and change the point size, so remember I'm working in millimeters here, so if we make that 1000, let's see, still not big enough. There we go, so we can see that we have one plane for every single line right there. It's probably a bit too big. Let's just change that, make it half the size. Yeah, there we go. So we've got one plane. So, so now really we're ready to start thinking about, well, how, if this is going to control, this curve here is going to control the shape of the stadium as we go around, how do we need to reference that in?